So this semester is going to have a whole lot more memorization than last semester did. This semester has a lot of stuff that goes on. So we do have the same textbook as last semester. So if you were in Miss Blaze's class, it's that same book. You do not have to necessarily carry it around. I do have PDF scans up on the Canvas page, and that's on my list today to make sure all those are up to date for the current chapter. I'm going to pass out the schedule thingy that has literally every homework assignment from now until the next chapter test, which is Friday, February the 7th. Okay, so this has all the things. It has all the quizzes on here. All that jazz. I reserve the right to push something back. I will not pull it forward because that's just me. There is also a digital version of this. If you don't want to have a paper copy, I get it. But I make them, you have them. No, you cannot say you didn't know that there was someone. Here's this. So I already hear several of you noticing that there's a surprising number of quizzes on here. After MLK Day, we will have a little speed quiz on something called the unit circle, which you don't know yet. We will talk about that when we get to it. I think by the end of the week we'll introduce it. But it's going to be one of those things, we will speed quiz on those. Like old school memorization table speed quiz. I will give you a blank one, you will fill it in. It is either correct or it is not correct. I have never had anyone not get it eventually. We have 3 that are scheduled in class. If it takes more than that, you'd have to come in either in study time or after school to do more attempts on it. We will have 3 minutes to fill in the whole thing. And it's just one of those speed quizzes. I've never had somebody not get it. So, just saying. So we'll get there, but it's just one of those things. That's why if you look after MLK Day, it looks like we have an obscene number of quizzes. 3 of them are 3 minutes, literally 3 minutes long. But there is a lot more memorization this semester. There's just a lot of formulas and a lot of things we have to memorize. So we're going to start with things that are a little bit more familiar. Today and tomorrow will be a lot more familiar, and then it starts to get a little weird. There's a lot of trig. So sine, cosine, tangent, those kind of guys, we'll work with them a lot. So you will need a notebook or a binder. I don't care how you do it. We're going to take notes pretty much every day. I have notebooks if you're in desperate need of one. If you got your own, more power to you. But we will be taking notes every day, starting today. So if you need a notebook, I can get you one. If you just want scratch paper because you have a notebook that you like, you just left it at home because it's first day of school, I get that, and I can give you scratch paper. But we are going to start with notes today. I've got a couple more things I'm going to say before we get there. Once again, IU sets the final, so I don't get to pick it or pick the questions on it. I'm working with what they give me on things that they say they're going to cover. Hopefully we do all right. Last semester we did all right. Hopefully same this time, so we'll see how it goes. If it gets to be close to finals and they send me something that's a little off the wall, we may just have a surprise section or 2 that we just go back and do something really random on. It's happened before. So, real quick about me, for those of you that don't know me, because I know I do have some new friends in here. My last name is Bieshki. That's how you say it, Bieshki. You can call me Mrs. B, totally fine. It's a weird one. I'm married into it. No judgment. I also keep it phonetically the same kind of way on the board over there on the other side of this screen. You can call me Mrs. B. Only downside with that is there are literally 5 Mrs. B's who teach math in this school, 4 of whom are my neighbors. Literally these next 4 classrooms are all Mrs. B's who teach math. I don't know why. We all married into them, but so I live in district. My kids go to Napa and Fishback. I have a 5th grader and a 7th grader. And I actually attended here. That is me as a Mystique. That one's me. That's the girl who's currently on Disney Plus in the WandaVision show. That's her. She was Mystique as well. My little friendly thing. We were in show choir together. But yeah, that's kind of the vibe. That's me in a real fast nutshell. One other thing that tends to be well loved in this class is the blinking rainbow problem in the back over there. Super subtle, blinks rainbows. That is weekly extra credit. I was like, I change them out every Friday. The little papers in the little box are for you guys to do it.
Did you have that last semester?
Yes, with the blinking rainbow lights. I was gonna say, it's back there. I change it out every Friday. I put the answer up on the wall for the previous week's question. If you turn it in after the answer's posted, it doesn't count. But I only change about at the end of the day on Friday. So, let's say, but you get the whole week to work on it. It's always either math review, logic, a puzzle of some way, shape, or form. Sometimes it's a riddle. But just kind of a thing, just because I know a lot of people didn't notice it last semester. So, but yeah, that's kind of the vibe. Homework gets done on paper, then you'll turn it in that big white bucket that's right by the door that says turn in very large. Everything gets turned in there. And mix it all together. Don't put it on my desk. That is the black hole. If you put it on my desk, assume it's been thrown away because it got lost. Don't put things on my desk. Bad idea. Okay? Kind of the vibe. So we are going to start with some words that we should have known. We usually start with like vocab or kind of like our overarching phrase or whatever we're going to do today. So hopefully this makes us a little less stressed about what we're going to do. We're going to talk about some angles. These should not be new words. It may take us a minute to remember a couple of them, but they should not be new. I'm talking more than I have in the last 2 weeks entirely. All right. So let's see what we remember about some angles, because we probably haven't talked about these since geometry. What's a right angle? 90 degrees. It has to be 90 degrees exactly. So right angles are exactly 90 degrees. How about an acute angle? Less than 90 degrees. They're so little and cute. Less than 90 degrees. How about an obtuse angle? Greater than 90. I think we know these words. Greater than 90 degrees. These are the ones going to take us a second for our brains to pull them out of the deep storage. How about a complementary angle? They add up to 90. So it's two angles. Ooh, that's too close together. Two angles whose sum is 90 degrees. When we are working with angles this semester, a lot of times we're going to need variables for them. And kind of the traditional thing to do in math is when we're talking about an angle, it's going to be a Greek letter. So I have a list up here. I'm probably going to go laminate these together, one over here and one over there, of common Greek letters that we're going to be using. Our most common are going to be theta, this one here, pi, which y'all should know, alpha and beta. Making a mess. Did I just spilled my water? But so when we're talking about angles, we typically use Greek letters. If we're talking about things like sides or legs, because we'll talk about triangles a lot, so sides or legs of triangles will be English letters. So we'll still use A, B, C, X, and Y, but we're also going to use alpha, beta, theta as our most common. So when we're talking about the angle whose sum is 90, if we're writing this in our Greek notation, it's going to be alpha plus beta equals 90 degrees. So alpha kind of looks like an A mixed with a fish. Like I draw it like this and then like that. That's how I draw alpha. Beta is a capital B with an extra tail. The other one we're going to use most common is theta, and it looks kind of like that. When we get to it, I'll show you. All right. So how about for supplementary angles? If complementary is the angle whose sum is 90, what are supplementary angles? Yep. Two angles whose sum is 180 degrees. So again, I'm going to put it in that Greek notation where I have alpha and beta is 180 degrees. And we go until... Okay, cool. 10 more minutes. We're in good shape. Because we are, we've worked with angles, we've worked with degrees before. We're not going to be getting out things like protractors and measuring angles that way. That's not the vibe. We're going to be doing a lot of calculation with angles. And where things like degrees come into play, real world would be things like longitude, latitude, where if we have 0 is usually the equator and 90 would be the North Pole. If you think about those as degrees, there is a lot of space between those degrees. So if I'm looking at 36 latitude versus 35 latitude, it's like half a state. Like, they're big. So we need a way to make them be more precise. So we're going to start with being able to convert units in degrees. So in order to mark something with precision, we have these kind of units here. So we have degrees, and we know our right angles are 90 degrees. But if I want to look in between degrees, we need to be able to have more specificity. So 1 degree is the same thing as 60 minutes. So we're going to use minutes and seconds just like time. And 1 minute is 60 seconds. And we tend to use an apostrophe for minutes and a double apostrophe or a quote or just a 2 slashes for seconds. And we're going to use this basically as a unit conversion to take things like decimals and be able to make them be more precise. And so we're going to want to have these marked down. So 1 degree is the same thing as 60 minutes, and 1 minute is the same as 60 seconds. So it converts the same way that time does, but we're just going to be really precise with it. So we're going to have some angles that we can write in a few different ways, because we're going to write these using minutes and seconds, and we're going to round things to the nearest second for this. But I'm going to start with 90 degrees here, our right angle, because there's a few ways I can write it that are going to be helpful in different situations. I can absolutely write it as 90 degrees. Great, we love that. I could also write this, my theta, as 90 degrees, 0 minutes, and 0 seconds. Totally valid, absolutely a thing. That's using minutes and seconds. But I also want to think about if I was trying to look for like a complementary angle or a supplementary angle, we might have decimals and things. And so this is something that's going to come up in a couple more slides. So another way I could write 90 degrees is to put this as 89 degrees and 60 minutes. Because if I have 60 minutes, that's 1 whole degree. It still totals up to 90 degrees. It's just written in a weird way. I could go even further with that, and I could write my theta as 89 degrees, 59 minutes, and 60 seconds. These things all mean the same thing. These all total up to 90. There's just going to be times if we're looking for like a complementary or supplementary angle that being able to write something like this is going to be easier to work with than if it was as a whole 90. Because 60 minutes would give us 1 more degree, which would get us up to 60 minutes, 60 seconds gets us 1 more degree, which would put us up at 60 minutes. 60 minutes is a whole degree, so that would put us back at 90. So if I was to simplify this and combine like my like terms here, I would get back to our 90 degrees. It's the same exact thing. It's just written out weird. And this is going to be one of those things that's going to be really, really helpful tomorrow when we're finding supplementary and complementary angles. Being able to write it like this is going to be helpful for that. Otherwise, it's really easy to get lost on that. So I know it's overcomplicating it. It is. It just is. Making it overcomplicated, but it's going to be helpful when we're looking for complementary and supplementary angles. More often than not, what we're going to be doing is something like this, where I'm trying to take a decimal and get that in degrees, minutes, and seconds. So if I have 45.25 degrees, what that means on our theta here is I have 45 degrees and 0.25 of another degree. So what can I do to take that 0.25 degrees and make that be in minutes? What could I do? Yeah. We're going to take our 0.25 times 60 minutes per 1 degree. Think of it like a unit conversion. If I was converting feet to inches, if I had 2 feet, well, 2 feet times 12 would be how many inches that is. So this is 0.25 of a degree times 60 minutes will give us what? 15 minutes. So this is going to be 45 degrees, 15 minutes. So we do this very much like a unit conversion. Think of this as 60 minutes per 1 degree, or 1 degree per 60 minutes if we're going the other direction. We're going to practice that again. This one will probably be our last one for today, because that'll be where I ended with my previous class. All right. So let's do this one. So we're going to have theta is 54.1269 degrees. And we want to convert this to degrees and minutes and seconds. So we have 54 whole degrees. So my theta is 54 degrees. And then I need to take my 0.1269 degrees, and we need to switch this into the minutes. So what are we going to do for that? What are we going to use? How do I get it into minutes? 60 over 1. 60, minutes per 1 degree. If you think of it as a unit conversion, my degrees cancel out. 0.1269 times 60. So what do we get when we do our 0.1269 times 60? If you already need a calculator, I got them over there by the flags. Flag.
7.614?
7.614. So this is the same thing as if I had 54 degrees and 7.614 minutes. But I don't want to have 0.614 minutes. That's icky. So we want to do the same process again, but to get seconds this time. So we're going to have our 54 degrees, 7 minutes, and we're going to take our decimal here, our 0.614 minutes. How am I going to convert that to be seconds? By? Yeah. 60 seconds in 1 minute. What do we get when we take our 0.614 times 60? 36.84. And that is our seconds. So if we're rounding to the nearest second, what are we going to have? Nearest. 37 seconds. Okay. So we are going to keep working with this tomorrow. I just wanted to give us our pieces on here. I'm going to put up the last page, which will always have the homework questions. It'll be the same that's on the paper. And I'll see you guys tomorrow, where we will hopefully have an entire period to actually go through stuff. Oh my gosh, what? If you have a different teacher period than you had last semester, and you need to know what last period you have. Let me know. Yeah.
Yes. It's like smoking all around him.
Ask him. I'm crying, bro. Last year, bro. Last semester I had last year, bro. And then this semester, just like this semester, I
I gotta be dictionary. Alright.
So you know this semester.
As long as I get that college credit, you know, I don't care.
I just like almost lost. Like, I forgot my stuff. He's probably going away to my own. Okay.
Okay.
Alright, don't.
I have used my iPad before.
Hold on.